Okay, now let us look at the timing diagram of an instruction known as STA. Suppose we are given an instruction STA 3070. See, what this instruction does is, it is going to store the contents of accumulator at this memory location, at memory location 3070. This is what the instruction does. Suppose accumulator holds, suppose the contents of accumulator are 08H. So after execution of this instruction, what is going to happen? 08H is going to be stored at memory location 3070. So now just let us look at the timing diagram. So if we suppose the starting address for this instruction is 5000H, this instruction is starting at 5000H. So what is going to happen? First of all, we are going to put 5000 in the address bus, 50 in the first 8 bits of the address lines and 00 in the next 8 lines. So I am going to put, these are the first 8 bits of the address line and these are the next 8 bits of the multiplexed address cum data bus. So we are going to put 50 here and 00 here, and along with this we are going to enable the address latch enable, that is we are making ALE1. Okay, already we have seen that unless we are going to make this ALE1, this is not going to act as address bus. Okay, this is a multiplex bus, this can act as address bus as well as data bus. So when we want to use it as address bus, we have to give this instruction ALE1. Okay, so as soon as we have made ALE1, this is going to act as address bus. The address 5000 is going to be loaded in the PC program counter, and from that location, okay, from that location we are going to, okay, this has no use, so this will stay as it is. Fine. So now this is going to act as soon as you make ALE low, ALE is 0, this is going to act as data bus. This is going to act as data bus. Now what data is it going to get? At 5000 we have this instruction, we have this opcode STA. So STA is going to come in the data bus, ALE is low. Also, to read this instruction from memory, we are going to give read bar. This is read bar. See, since this read is active low, we are going to make it 0 for these two clock pulses. So now you have got the instruction STA. Okay, and this is the decoding cycle. Decoding cycle. Here contents of this address bus are unspecified, and so that the contents of this data bus does not change, it is made high impedance. This is high impedance. Fine, so decoding takes place in this cycle. After decoding, the microprocessor knows that now the contents of the accumulator have to be stored. Now what do we need? After we know that contents of accumulator have to be stored, we need the memory, we need the address of the location where the contents have to be stored. So again what we are going to do, see, this instruction is a 3-byte instruction. How? This opcode takes 1 byte, these 2 bits take 1 byte and these 2 bits take 1 byte. Also, one more thing that you can note here is, whenever we store address in memory, whenever you are going to store some address like 3070, the next location 5001 will contain this address and 5002 will contain this address. See, you can remember this as lower bit of the address is going to be stored in the lower address, higher bit of the address is going to be stored in the higher address. So firstly we are going to get 70, then we are going to bring 30. So what happens in the next cycle? In the next cycle again now we are going to put the next address. What is the next address? 50. This is is going to hold 0 1 0 1. Again I am going to just make this ALE 1, ALE is going to be 1, so that this acts as an address bus. ALE is 1, this acts as address bus. So now we have reached the location 5001. After you reach 5001, what is stored there? These bits LSB of the address are stored there. Now we want to read this, so what do we do? What is going to come now? 70 is going to be read from the memory. We are going to read 70 from the memory. ALE is low, so that this acts as data bus, and also you are going to make this read bar 0 for 2 clock pulses. Read bar is 0, that is we have now got 70 in the microprocessor. Now what happens? See, now we have got the LSB, the least 2 bits of the address. Now we require 30. So what do we do? Again same thing. You are going to put 50 here. See, PC gets incremented after every clock cycle. After every instruction, completion of instruction, PC is going to increment. Initially value of PC was 5000, so 5000 was loaded in the address bus. After the opcode was fetched, after we knew the instruction STA, in PC got incremented, 5001 was placed on the address bus. Now we have got the least 2 bits of the address, again PC is going to increment and you are going to get 5002 here. Now see, what is stored in 5002? 30. Okay, for this you are going to make ALE 1 of course. Again when ALE is low, this address is going to be read. When you read this address, you are going to get 30. We are going to make read bar 0. See, since read line, this instruction is active low signal, that is why I am making read bar 0 to read the address. Okay, now see what all has present with the microprocessor. The microprocessor knows the instruction, that is the contents of the accumulator are to be stored in some memory location. Also we have got the location of the memory. Memory location is 3070. Now what do? We store on PC. PC is going to be overwritten with this memory location. 3070 is going to be overwritten on the PC. We reach that location and write the contents of the accumulator there. Okay, fine. So what happens in the next cycle? The next cycle, here what are going to be the contents of this address lines? The upper bits of the address line are going to hold 30, lower bits are going to hold 70. For this to act as address bus, I am again enabling the address latch enable. Okay, nothing is to be read, so I guess this is going to be high. Now what happens when you reach the location 3070, we wish to write the contents of accumulator. Suppose contents of the accumulator was 08, so what do? You are going to place 08 in the data bus. Here we are going to place 08. Now these were the contents of the accumulator, these have been put in the data bus. Now I am going to write these contents on this location. For that, what do I have to do? There is another line known as write bar. So for these 2 cycles, this is also active low signal. For these 2 cycles, I am going to make write bar as 0. As soon as you make write bar 0, this particular data is going to be written at the location 3070. So this is a timing diagram for storing the contents of accumulator at a particular memory location. Okay, next we are going to look the timing diagram for input output write or input output read. Okay, so this is the last timing diagram. This is for an instruction which we use for input output write. See, all the instructions that we have seen previously, they were working with the memory. We were reading something from the memory, writing something to the memory, or some operations were done inside the microprocessor. Now this particular timing diagram shows how the working is going to be when we are going to write something to the input output devices or read something from the input output devices. Suppose you have given a command that you want to display a particular number, a particular data on the screen. So you are using a command, suppose you are using a command out6ch, which means that there is an input output device at this address and we just want to output some data on this address. So see, what do we do? Okay, starting address for this we are assuming as 2000. Suppose this starts at 2000. So initially we know what we are going to do is we are just going to place 20 on the first 8 bits of the address bus, and on the multiplex bus AD7 to AD0 means we are going to place 00. When you do this, what do you get? You get out. Okay, I think this part is clear, so I am taking it quickly. Out is going to come here. Of course, you are going to make ALE1 for this to act as the address bus, and to read this instruction you are going to make read bar is going to be 0 for these 2 cycles. This is ALE, this is read bar. Okay, fine. So now we have got the instruction, we have fetched the opcode out. Okay, so now the microprocessor knows that you are trying to output some data. Okay, this is going to be the decoding stage. At the time of decoding, the contents of this address bus are going to be unspecified, and this is going to be high impedance. Fine. After this, when we have got the instruction out, what we are going to do is, after you got the instruction, we jump to the next address. Address is going to be incremented. Okay. So PC gets incremented, the address 2001 gets loaded. For this ALE equal to 1. For this I am going to enable the address latch. Now what is going to come in the data bus? This address was stored at 2001, so you are going to get 6C loaded in the data bus. To read this data from the memory, this read bar is active low signal, so I am making it as 0. Now this data has been read. Now what happens? Now see, the microprocessor knows that something has to be output, and at what address? At 6C. But see, the problem is the address bus that we have got is a 16-bit address bus, and the address at which you are supposed to output this is a 8-bit address. This 6C is a 8-bit address. So now this point is important. What happens is, when we have a 8-bit address but the data bus is 16-bit, there is something known as address duplication. That is, in both the higher 8 bits and at lower 8 bits, you are going to give the address as 6C only. 6C will be given in both the upper 8 bits of the address bus as well as in the lower 8 bits of the address bus. Okay, this is something known as address duplication. Okay, this is an important and very innovative concept of 8085. This is known as address duplication. Okay, fine. So now I have got the address. ALE is again made 1, of course. Okay. Now suppose the contents of accumulator or anything that you wanted to output, okay, let us suppose it was 15. So now you have reached the address, you have the data and you want to write this data. So you know what you are going to do. This is write bar. For 2 clock cycles you make write bar 0, write bar 0. Okay, then when we looked at the architecture of 8085, you might remember we had a pin known as IO/M bar. See, what is the function of this pin? This pin selects whether we are working with the input output devices or with the memory. If this pin is low, that is if the status of this pin is 0, then this memory is active, that is you are working with the memory. If this IO pin, this IO/M bar pin is 1, you are working with the input output. So what do we do? For all this duration this pin has been low, but here when you want to work with the memory, you want to write in the memory, you just make this pin as 1. We are going to make IO/M bar as 1 here. This is IO/M bar. Okay, so there are only two things that are different from other instructions. One thing is address duplication takes place in input output read write, and the other thing is you have to make this pin IO/M bar as 1 to write or read something from the memory. Okay, this is going to be 1 here. Okay, now again just look, the first 4 T states, first 4 clock cycles till here, we are just doing opcode fetch. This is opcode fetch for 4 T states. Next 3 cycles, what are we doing? These 3 cycles are used for memory read, 3 T states. And the last 3 states, what we are doing is IO write. IO write is input output write. This is taking 3 T states. So this instruction out 6CH, this comprises of 3 machine cycles, opcode fetch, memory read and IO write. Each opcode fetch is of 4 T states, memory read 3 T states and IO write 3 T states. So totally it is going to take 10 T states, and also size of this instruction is 2 bytes. 1 byte is for this opcode and 1 byte for the address. Okay.